Hello there, in today's tutorial we are going to talk about how to model, design and analyze the rectangular water tanks using ETABS software. So let's start. I will go here to the open or new model, afterward model initialization, then I will use built-in setting width and I will choose display unit as a metric standard international, and the still section database will be this one, and also the still design code will be this one related to the structure, and after concrete design code will be American Concrete Institute 318 2019. Then I will proceed. Now I will choose here the number of stories will be 5, and the typical story in bottom story height will be 3 meter. And I will choose here the number of grid lines in 4, 4 and also 3 and 3. Afterward I will modify also, and I will choose the grid only, press OK. Now we have Model Explorer window, window 1, window 2. So like this one will be used for 3D view, this is the plan view, and this is Window Explorer, which I do not need at the moment. Now I will come here to modify grids. So we'll come modify to the story height. I will change here this, the 5th story will be 5 meter and the others will be 3 meter. Okay, the total elevation height of the tank, rectangular water tank, will be 17 meter. So afterward I'll press OK. Then I will modify here the grid system, modify. I will select here the display grid data as spacing. I will change here this 3.3 meter and 3.3 meter. I will delete this one, there is no need. And here for the Y grid information, this is 3 meter, 3 meter. I will delete this one, no need. Afterward I will change here the bubble size, like I will change here to the 900 mm. I will press OK and I'll press OK again. Now coming here, so now I will define the material properties. I will just modify the show the existing material, and I will use the 4000 psi as a concrete material. I will change the unit weight per welding will be 25, and here this will be 30,000 megapascal, and this is the percentage ratio and others. Afterward I will come here, modify. I will change here to the 25, 30,000 and press OK. I will modify here this name, this is the rebar material, OK, and afterward I will press OK. So I will use the material as a 4000 psi for concrete material and 64 rebar materials. Afterward I am coming here to define the frame section properties. I will delete some multiple properties which I do not need, so I will delete all these. I will add a new property here as a concrete rectangular in shape. I will choose here the concrete rectangular, so I will give a name here, column 0.5 by 0.5 meters, and I will choose here the material as a 4000 psi, and here it is depth is 500 mm and it is width is 500 mm as well. I will come here to the modifiers. I will change here the moment of inertia about axis 2 will be 0.7, and here about moment of inertia about axis 3 will be 0.7 as well. Now I'm coming here to the rebar, and I will choose here the PM3M3 For columns, I will choose here the 60. For rivers, I will do not change all the other properties. I will press OK. Now I'm coming in. OK. I will define here the concrete sections. Here the rectangular beam will be 0.35 meter by 0.35 meter. I will choose here the 4000 psi as a material, concrete material. I will change here 350 and also 350 as a width. I will do not change these modifiers, but I will change here for the 3 beams in the same material. For rebars, I will press OK, then proceed. I will delete this one. So I have defined beams in column sections. I will now define here wall section here. So I will add a new property. I will name it to 50 mm as a wall, shear wall. So I will select the 4000 psi material, and the modeling type will be shell thin. It is a property, the thickness will be 250 mm, and I will press OK. I will delete the previous one. I will press OK. Now I'm coming here to define the slab sections here. So I will add new property. I will give a name here, bottom slab. Okay, I will use the slab material 4000 psi, and here the shell thin modeling type, and the property type is slab, and here the thickness is 300 mm, and proceed. I will delete this one. So now I will add new property again. I will give a name here, roof slab 150 mm. I will choose here the same material and shell thin. It is modeling type, and here the property is slab, and I will choose put here 150 mm as a thickness. I will press OK, then OK. Now I'm coming here, like I have defined the material properties, the section frame section properties, and also wall and for slab, roof and bottom slab. Now I'm going to practically create and model the structure or water tank, the rectangular water tank. So I'm coming here to the shear wall sections. I will choose here the draw wall. Afterward, I will choose here the wall section property, and I will choose here a single story. I'm coming here to the story 5. I will now press this grid and come here. Look the preview in, it is 3D as well, and press here, then come here down, sorry. So I will just undo one step back. I will select this one, wall, select this grid point and come here, this one. So if you want to just quickly draw the wall, you will choose here the quick draw wall and choose the wall property and just click on this here, look here, and it is 3D view also, it is showing here and here. After its completion, just skip here. Now come to the 3D view, rotate and see this is the water tank walls, the rectangular water tank. Now I'm coming here to draw the column. I will come here to the column, click draw columns, and I will choose here the column property which I have defined here, the column. I will select here all stories and I will draw a column here, 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 and finally to this side. Look here, the column has been also drawn for this water tank. Now I'm coming here down. I will draw the beams here. I will choose the property as a beams. Now I will select all stories. I will just simply click here. I will choose this one, and it is property is beams. I will simply click this one and drag here and place the cursor. All the columns has been created. Look here. So if you want to just delete some beams, I will go move up. I will go one step above. I will come here, select a single one story. I will select these beams because there is a wall and no need for these beams here. I will select these beams and I will simply delete. Look here, there is a wall, so no need for beams here. Now coming here to draw the slabs here. So the property type is roof slab. I will select here, from here to here, here is point, also here, and finally back to the initial point. So look here, this slab has been created. Now I'm coming one step down here. This time I will select this slab to draw and just drag. If you wanna just quickly draw the slabs, you will choose this one. Just by one click you can create a slab. Now I'm just coming here to choose the bottom slab here. So now I will come here, select this grid point and will drag to the other grid point and release the mouse. Okay, so now I have created both the slabs, walls and also beams and columns. Now I'm coming here to its base down. Sorry, this is 3D view. I will select this window. I will come here to the plan view base here. I will select all these nodes. I will assign it as joints as auto strings. I will select here fixed, or you can just select all these boxes. I will apply OK. After assigning it is supports, I will come here to define it is load patterns. I will define here earthquake x-axis. I will choose here as a seismic. I will choose the code American Society of Civil Engineering 716, add x negative direction, the same code add, and also here the y-axis positive. the seismic type, and the same American standard, the negative Y, the same code. Now it is wind X, the type will be wind here, and also the American standard or American Society of Civil Engineering 716, and here for Y as well. Now coming here as a wind, as a water pressure, because this is a water tank, I will choose here. The water pressure option does not exist, so I will choose others and I will add. Now I'm coming here to modify the earthquake or seismic earthquake records here, or it is load patterns. I will choose here the X directions plus eccentricity, and I will uncheck all other boxes, and I will put here the spectral acceleration SS as a 1.15 and spectral acceleration S1 as a 0.5. Here the site class will be C, and the time period will be program calculated, and here the response spectrum will be 8 and 3, and I will do not change others as well. I'll press OK. Now coming here to modify this earthquake about X negative directions, I will choose here the X directions minus eccentricity. I will uncheck other boxes. I will put here 1.15 and also 0.5 and site class is C. Other properties I will not change. I will press OK. Now coming to the earthquake Y, I will uncheck others but remain Y directions plus eccentricity. I will change the spectral acceleration as 1.15 and also this 1.5, and the site class will be C. I will do not change other factors. Press OK. Now coming to the Y earthquake Y load pattern, I will uncheck others but remain Y directions minus eccentricity. 1.15 will be spectral acceleration SS, and this one will be 0.5, and the site class will be C, and other factors is the same here, but I will press OK and will modify here the wind x-axis. The exposure will be from extents of diaphragm. The wind speed will be 100 mph, and here the exposure will be B, and other factor is as it is, and here the exposure height will be from story first up to the top story, and other properties is the same as it is chosen by the system. I press OK. I will come to the wind Y and exposure. The wind speed is 100, and other properties like exposure height will be from story 1 here. Other properties is correct. I will press OK, and there is no need to modify the water pressure. I will press OK. So now I have defined the load patterns. Now I will define here the load combinations. I will come here to our default design combo concrete frame. I will OK, and here all the 26 load combination will be added here. I will press OK. Now I am coming here to define the mass source. I will define new mass source. I will name it mass source. I will come here to select here the specified load pattern. The dead load modifier is 1, and also for live load modifier is 0.25. I will add it and will press OK. This is the default mass source which I have defined. Now I will delete the previous mass source and press OK. Now I am coming here to define the function for response spectrum. Here I will choose the code here 716, and I will add new function. I will define here the target response spectrum. I will choose here the spectral acceleration as a 1.15, and also S1 will be 0.5, and here the side exposure will be C, and it is damping ratio will be 5%. Look here, and this is the points for period, and here is the points for acceleration. Afterward you can press convert user defined or simply press OK. So then the target response will define. This is the target response spectrum, and I will delete this one. I'll press OK. Now I'm coming here to define the function for time history. So it will be from file, but before that I should have some earthquake records which will be taken from one of the website, which I have explained also in previous video. Which you do not understand how to get the earthquake records, watch that tutorial, which link is in the description box below. So first I will do not define the time history. I will go for earthquake record. Come here, time history. I will select here the choose function type is from file, add new function. I will browse it, that earthquake record. This is the earthquake record for Italy x-axis. I will open it. So I will see the file first. Look here, the header lines to be skipped. It is 4, 1, 2, 3, 4. The 4 lines should be skipped. And here the number of points per line is, look here, 1, 2, 3, 4, and this is 5. I will put here 5, and the time difference or the time difference interval is here 0.0024. I will put here 0.0024 as a time difference. Look here, this is the earthquake record, the time history earthquake record about earthquake x-axis. Look here, I will name it time history for Italy earthquake record X. I will press OK. So this time history function will define. Look here, we have defined. I will select this, the predefined functions. I will add again for earthquake y-axis. I will browse the file here for Italy earthquake record about y-axis. I will view the file, but it is the same file. The 4 lines to be skipped, and the number of points per line is 5. Look here, when I'm just putting the correct points, the graph is also changing. I will change here the 2, 4, the difference, the time difference. Look here, this is the time history graph, earthquake record or history for Italy earthquake record about y-axis, like time history of Italy earthquake record earthquake about y-axis. I will press OK as well. So I have defined the time history about x-axis and y-axis for the time history. Now I'm going to choose the function. I would like to match the response spectrum, which I have defined it before, to this earthquake records which I have defined now. I will select here the matched to response spectrum. I will add new function. I will give a name here, matched response spectrum with earthquake about x-axis. So I will choose here the target response spectrum will be this one which I have defined, and here the reference acceleration time history will be earthquake about x-axis, and it is units will be g units. Look here, Now there is some parameters to be set here. It is okay. Now we have two options here in this method for spectral matching. One is the spectral matching in frequency domain, one is the spectral matching for time domain. Okay, you can do for anyone you want, but I will do here for the time domain. After that I will match time history. So it is going to match the response spectrum with earthquake records about x-axis, the matched one, the matched time history. It will take some time. After a while we will see its results. So the target and the time history graph has been matched. So this is the matched one, and now I will press OK. Now I am going to define here for this is the matched response spectrum with earthquake x-axis, and I will define here to match the earthquake record about earthquake y-axis time. No, okay, matched response spectrum with earthquake y. Okay, now I will come here to select the spectral match in time domain and target response spectrum about this one, and also about time history earthquake y-axis. The unit is G unit, and I will choose here the match time history. So the target response spectrum has been matched with time history earthquake record y-axis as well. I will press OK. Then look here, this is the matched one or synthetic earthquake records, and this is the real earthquake records about x and y axis. Afterward I'll press OK. Now I'm coming here to define what. So I have defined everything, there is nothing remain. Now I'm coming here to apply, to select here about object type, select all columns here. So I will apply here, assign the frame load distribution here. It is dead load, and I will just calculate for column dead load here. Like the column thickness is 0.5 multiply 0.5 and also multiply with 2.5, which is the unit weight, and 6.25. It is 6.25. I will apply and OK. So now I will select here, coming to select object type here, select beams, select all the beams. Now I am coming here to assign the frame load distribution. I will calculate here for beams. So beam was 0.35 multiply 0.35 multiply with 25. It is 3.06. Okay, I will apply and OK. So now I'm coming here to select here object type as a wall. I will assign here the shell load uniform it is the dead load pattern, and I will choose here. So I will calculate for wall as well. So the wall thickness is 0.25 multiply with 25, so it is 6.25. So 6.25 I will apply. Okay, now I will select here, select properties and also the slab sections, the bottom slab, select and close. I will assign it as shell load here, uniform. I will select it as dead load. Okay, the slab thickness is 0.3 multiply with 25, it is 7.5 here. Add to the existing load, apply. Okay, now I'm coming here again, select the previous selection, which is the bottom slabs, and I will select also here the object type as a wall. Okay, this is the water tank faults. I will assign here the water pressure, the shell load uniform. I will select here the water pressure, which I will apply 5 kilonewton per meter square. Apply. Okay, so I will select here the object or properties as a slab here. Okay, I will select here object type as a slab. I will select here the floors, select both the slabs, and I will apply here the uniform, this time live load, and I will apply 1.46 kilonewton per meter squares. Add to the existing load, apply, and okay. So now everything is complete. Now I will select all the stories here, the floors, object type, select all the floors, select close, and assign here the shell, assign diaphragms. I will select D1, apply. Okay, so I have defined the diaphragm as well. So I have defined everything. I will go for run analysis now. So now everything is complete. I will go for here the run analysis. So the analysis will start and will complete it shortly. So the analysis has been completed. You can just go through for start animation. So the animation will start. This is the animation of the water tank. So I will close it. Afterward, I'm coming here to go for the concrete frame, and here the design check, start design check. So it will check and start the design for concrete frame sections. The design check has been completed here. Look here, I will come here and verify all members passed. It is showing that 3 concrete frames failed the design check, so I have to select all that failed sections for members. Okay, look here, 1, 2, 3. These 3 beams has been filled, so I will just increase it is cross sections or change it is some properties. I will save the diagram here, and look here, this is a beam. Stresses, sway intermediate, okay, and here for this one as well. Okay, I have done this one. For this one, sway intermediate, okay, I have changed all, so I will go for design check again. Three concrete frames has been filled, so I will unlock first. So I have unlocked the structure. I will increase the beam cross section to 0.4 by 0.4, like 400 mm, and width and depth the same, 400 mm. Afterward, I will press OK. I will assign these properties, frame and here section properties, this 400 apply, OK. Afterward, I will go through for run analysis again. Look here, the analysis has been completed. So it is just refreshing the window. Yeah, it has been completed. Now I will go again for the concrete frame section check, design check. It will see whether those beams which were filled in previous design check now it is passed or not. I will come here again and verify all members passed. Still these columns are not passed. I will unlock again. I will select all the columns, sorry, beams. I will select all the beams and will assign here the frame section property as a beam. Apply OK. So now all the beams cross section is 400 mm by 400 mm. I have increased. So now I'm going again for run analysis and see in the design check whether all members is going to pass or not. If did not pass, so I will increase some reinforcement or increase the cross section of those members. So the design or the analysis has been completed. Now I will go for concrete frame design check. The design check has been completed. So now see whether the members is going to pass or not. Verify all member passed. So we'll see its reason. Just look here. It is showing that I should put a columns here in these portions because this is more distance and this is the water tank, which is very important. So I will put a column here. This two side I will unlock this one and I will select all stories. Look here, it is 3D as well. I will come here to the column. Here I will select these columns. Afterward I will select column, this column property, and I will select here and here. I will press OK. Now we will see whether all these beams is going to pass or not. So I'm coming here to it is base again. Okay, I will select a single story. I will fixed it is all these nodes, make it fixed. Okay. So I am going to run analysis again for third or fourth time. The analysis has been completed. Now I will go here for the concrete frame design check. Now I'm coming here again for verify all member passed. I will say it is reason. What is the reason? I will go here for sway intermediate, apply. Okay, I will set this beam. Sway intermediate. Okay, and I will check for this column beam, sorry, sway intermediate. Now I will check again. So now all member passed. So because I have increased the section properties of a beam from sections, okay, I have increased from 400 mm by 400 mm to 500 mm by 500 mm. Okay, look here, this is now the current beam section dimension. So afterward I'm coming here for the display diagram, moment, shear and moment diagram. Here look here, this is the shear force diagram. You can look here for their values as well. And this is the bending moment in 3-3. Okay, you can choose for load combination as well, like here. Or you can do for earthquake x-axis as well, and y-axis, earthquake y-axis as well. So it is up to you, and the mode shapes as you want. Here the mode number, one mode, second and third, whatever you want. The mode 7 and others. Okay, now I'm coming here. So it is undeformed shapes. If you want to just create or get some information about here, if you want to get some information like coming to the design forces here, or you can get from here where structure output like base reactions, you can press here and OK. Select here for earthquake x-axis and y-axis, earthquake x and earthquake y. Apply multiple filter. This is, look here, this is the base shear for earthquake x, and this is for earthquake y, the base shear. Okay, so if you want to just export it to the Excel sheet, you can do from here. So it will automatically transfer to the Excel sheet and you can use it. So it is just exporting the base shear result to Excel sheet. That's why the system has become slow a little bit. So if you want to just get some other information, like look here, like the period of the structures, you can get from here, and frequencies. Look here, this is the period of the structure of the water tank, and this is the frequencies. Okay, so and other information you can just get from and all these tables. Now I am coming here to the display to show here the story response plots. This is the maximum story displacement. Look here for earthquake X. This is the maximum story displacement. You can get it also at its values. Here it is location, it is directions in X. This is for earthquake axis, X axis, and for earthquake Y. Here this is for earthquake Y. So you can get here, it is story shear as well. Also you can get it is story stiffness, even the maximum story displacement here, and also you can get here the drift ratio and other information. So it was all about how to model, design and analysis of elevated rectangular water tank. Thank you so much for your attention, and do not forget to subscribe this channel, press the bell icon, and have a wonderful time. Bye bye.